Right, binary numbers. We think in decimal numbers. We think we count up to 10, and that's just dandy. We've got 10 fingers. It all works tidy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's brilliant. But our computers don't use binary. So don't use decimal. They use binary. Some early computers did use decimal, but now it's all binary. And it may seem a bit inconvenient, but in a way I can count up to an awful lot more. Binary is base 2. So in my old deanery, base 10, so I think units, tens, hundreds, thousands, and that might be number 9,999. That might be number 1,250, and that number might be number 30, which we'd write tidy like as 0030. Fine, that's the way we go. Now binary works exactly the same way, but I've not got 10 fingers. I've had some horrible, horrible mutation, and I've only got 2. Now if I've only got 2 fingers, units make sense, it's working that, lovely. Then I can have 2s, and that's in effect 2 to the power of 1. I can have 2 to the power of 2, which would be 4s. 2 to the power of 3, which would be 8s. Yeah. And we can go on and on and on like this, the basic principle we're going to play with. So if I've got a number in binary, that number will be 1, 2, and 1 unit, that's 3. We'd write it like this, put the leading zeros, 0011 is 3. This number is 1, 0, 0, 0, 1, 8, no 4s, no 2s, no units, got the number 8. You might think, oh, it's an awful lot of effort like this. Let's imagine again, due to some horrible mutation, I had 4 fingers, 4 little pinkies like this. If I was counting on my pinkies, I could count 1, 2, 3, 4, and I've had it. If these were my pinkies to count in binary, units, 2s, 4s, 8s, I can count 8, 4, 2, 1, 8, 12, 14. I can count to 15 with the same number of pinkies that took only 4 behind. So as an efficient way of counting, we can get some dangerous big numbers with a relatively small number of columns. Obvious things we can't do is we've only got 1. It's on, it's off. It's a 1 or a 0. So things that are obviously no-nos is it's just don't know where to start wrong. You can't do it, can't have it. You've only got 1 and you've got 0. This causes a few minor issues adding up. In our current way of thinking, in base 10, we might do that 4 plus 2 is 6. Makes sense like this. Now if we do 9 plus 1, 9 plus 1 is not going to be 91 or some unknown number. I go back to my 1s again. 9 plus 1 makes 1 10 and 1 unit, as you do. Binary, of course, works the same way. So in binary, 1 plus 0, that's 1. We can't go far wrong with that. Also 0 plus 0, going to be 0. Just watch out. If you want to do consider that 1 plus 1. I can't have 2, can't be done, not going to happen. So 1 plus 1 is 0, carry 1, it's 10. If you know that 1 plus 1 equals 10, it's no problem, it'll all work. If not, go back over here again. We've only got 1s, only got 0s. We've got a certain number of columns to work with. Here are 4 columns. 4 columns in traditional terminology is what we call a nibble. The more columns we've got, the bigger number we can count over. 4s, 8s, 16s or whatever. 2 nibbles or 8 columns is a byte. So if we had 8 columns, we could do as far as units, 2s, 4s, 8s, that's my first 4, 16, 32, 64, 1, 2, 3, 4, 5, 6, 7, 8. That's a byte. And not surprisingly, the largest number I can fit inside a byte would be all ones, 8 for the fruits. 4, 5, 6, 7, 8. And that number we could work out, add 1 to 8 to 64 to 32 to 16 and so forth. But we know the next column which we've not got is 256. So we know this number is 1 less than 256, hence it must be 255. If I only had 8 bytes and I added 1 to it, one plus 1 is 0, carry 1. 1 plus 1 is 0, carry 1. You can probably see a pattern over here. 4 more to go. 1 plus 1 is 0, carry 1. When I get to the final one, missed one somewhere. When I get to the final one, there's no room for it. It's going to fall off basically. So if I had 8 bits, or 1 byte to store my numbers in over there, and I added 1 to it, I'd go back, and then it was 0. So I've had to set a certain number of columns or areas inside my program, my memory, to store numbers. Obviously to do a single nimble 4 or a byte 8 would be way, way too small a number. So I want quite a large number of these things. But there will come a finite time when it's going to run out. You may notice in some of your programs that if you put too large a number, you have a for loop perhaps, and the for loop goes on and on and on because you've forgotten to put an end to the for loop. Eventually you get some sort of stack overflow error. It crashes because it's keep adding numbers and numbers and numbers. We get to the final line, we get to the final ending bit, we can't add any more to it and it falls off the end.